Howdy, AP PreCal. It is Miss Kosh. I saw something similar to these two problems that I just wrote on AP Classroom in section 312. So they are a little confusing, so let's just jump right in. This is not exactly what I saw there, but similar. Here we go. Okay, so I have this 3 sine theta plus 4 cosine theta can be written in the form k sine theta plus a, and then they'd say find k, and actually I think what I should specify is that k is greater than 0 and 0 is less than a is less than maybe or equal to, I don't know, 2 pi. Okay, so I'm giving some little guidance there. I want the k value to be positive because if it's not, we have lots of choices. Okay, so what I would suggest we do is start, we have an identity that will let us expand this out. So k times sine of theta plus a is going to be equal to, this is the sine one, what I remember is sine, cosine, cosine, sine with the same SIG in. So it's k times sine, cosine, cosine, sine with the same SIG in. Okay, and so now what I see is I have this k sine theta cosine alpha plus k cosine theta sine alpha. Oh, not sin. Anyway, I was ready to write that A too soon. Okay, so looking at this one here, we wanted to know, we have this now equal to this up here. So when I compare these, 3 sine theta compares to that term, plus 4 cosine theta would compare to that term. This allows me to write a system of equations. The 3, so sine theta, or what's left, k cosine out a, k cosine a is equal to 3. And over here, k sine a would be equal to 4. Okay, so now I have 2 variables, k and a, and 2 equations. So if I come over here, I can say that this k is equal to 3 over cosine of a. I can plug this in, and I have 3, well, what do we know? Okay, I'll show you all my steps. 3 over cosine a is getting multiplied by sine of a, and that's equal to 4. What do you know about sine over cosine? Hopefully you know that this is 3 tangent of a is equal to 4. Therefore, tangent of a will be equal to 4/3. Therefore, a will be equal to arctan of 4/3. Okay, and that's something, so here's our a value, and it's between, actually that one is between 0 and pi over 2 because the values are positive. But what I want to do now, I need to solve for k. So we're going to come over and draw this in quadrant 1. They said, not to scale apparently, but this is, tangent is, this is our angle A. Tangent is 4/3, opposite over adjacent. This is a 3, 4, 5 triangle. And so now what I know is that sine of A is equal to 4/5, and cosine of A is equal to 3/5. And I can come back and solve for k by coming into either of these equations back here. So I have right here, k times cosine of A. Well, do I know cosine of A? I do. I wrote it down over here. K times 3/5 is equal to 3. So multiply by the reciprocal, 5/3, the 3's cancel, and I have that k is equal to 5. I also had something similar that my HLIB kids had to investigate. This is kind of necessary. This is helpful for one of the practice paper 3s that I found for HL. So anyway, there's that information. So then I wrote a second problem. The difference being, this one was a nice little triple, and it had sine of alpha plus, or theta plus a. And this one is going to involve cosine, okay? And same restrictions on the variables. I didn't write that this time, but here you go. Okay, so let's start by taking k times cosine of theta. I keep wanting to call it alpha. I don't know why, that's wrong. Okay, and so this would be, the way I remember this one is cosine, cosine, sine, sine with the opposite SIG in. Oh, I wanted space. And then I'm going to, okay, I won't distribute the k. I'll do it in a minute. And then it's the first angle, the second angle, the first angle, the second angle, and there we go. Okay, so what do I have? I have k cosine theta cosine alpha. A, it's just an A. Goodness gracious. I'm used to seeing alpha and beta for angles. And so when I see this A, I want to call it alpha. I think that's what my brain's doing. And okay, so this term right here, 2 cosine theta, and this is a minus 3 sine theta. So let's compare these things. I have 2 will be equal to k cosine A. So k cosine A equals 2. And then over here, this is a negative, and those would cancel out. So then this 3 is going to be equal to k sine A is equal to 3. This is very similar to the last one. Now k is equal to 2 over cosine A. Plug this in over here, and I see a 2 tangent A is equal to 3. Therefore, tangent of A is equal to 3/2. So A will be equal to the arctan of 3/2. Thinking back to, or drawing this as a triangle, here arctan of 3, here's 2. 9 plus 4 is 13, so root 13 would be the other side. So what do we know? We know that sine of A would be equal to 3 over root 13. We know that cosine of A would be equal to 2 over root 13. And so then let's come back to one of those equations. Let's do the sine one, because a minute ago we used the cosine. And so I have k, sine of A, we just said was 3 over root 13 is equal to 3. Hopefully you can see that k would have to equal root 13. And so there's A and there's k. All right, like, subscribe, comment, let me know how I can help you. And of course, go practice.